Hello my dear bright students, welcome back to physics class. Your curiosity makes every class special. So let us continue our journey with today's topic, vertical projection of bodies from the top of a tower. I repeat, vertical projection of bodies from the top of a tower. Here we begin with. So to consider with, let us consider a tower of height h. Let us consider a tower of height h. From the top of a tower, let us suppose that a body is projected upwards. A body is projected upwards with some initial velocity u. Okay, this is the direction of projection of the body. Okay, and the body reaches maximum height where its velocity vanishes. So whenever a body is thrown with some velocity while going upwards, because of the gravitational pull, its velocity gradually decreases, and whenever it attains the maximum height, its velocity vanishes. So here the final velocity will be 0. When its velocity becomes 0, it again starts falling downwards because of the gravitational pull and reaches the ground. Okay. Remember that children, at this height, if the velocity of projection is u, in the downward motion, again at the same height, its velocity would again be 0. But this velocity is directed in the downward direction, whereas this velocity is directed in the upward direction. But children, one thing you need to remember, that the displacement in the projection of them in the direction of projection, body is displaced in this direction, upward motion it is thrown. The displacement in the direction of projection is taken as positive, whereas the displacement in the opposite, the body is projected upwards, if the body is coming downwards, the displacement in the opposite direction of the displacement, opposite direction of the projection is taken as negative. Clear, children? So as it was given that this length is h, let us suppose this length is some x. If this happens to be plus x, the displacement is plus x, then the displacement from the highest position to again this in the downward direction is taken as minus x. Similarly, from the ground to this height, if the length or height is taken as plus h, then this height is taken as minus h. I hope this point is clear, children. The displacement in the direction of projection is taken as positive. The displacement in the direction opposite to the direction of projection is taken as negative. Okay, again is the projection. So if you consider the total displacement of the body from here to here, again here to here, and again from this position to this position. So let me indicate this point A, B, C and D. The total displacement from A to B, again B to C, and again from C to D. So what is the displacement, children? From A to B, if you consider, the displacement was taken as plus x, and from again B to C, while traveling from B to C, it is taken as minus C, and again when it travels from C to D, its displacement is taken as, it is taken as minus x, and the displacement from C to D is taken as minus h. Okay, children. So based on that, so what is the total displacement, children? This is plus x, minus x and minus h is the total displacement of the body. Okay, and we know the formula S is equals to ut plus half at square is the generalized kinematic equation. Okay, hence instead of displacement, what you have written is, this is plus x, this downward direction is minus x, and again this downward direction is minus h. This blue color only indicates the projection. The journey of the body has started from here. Okay, so this length, this means plus x, minus x and minus h is equals to ut. So what velocity it was thrown, children? U in some time t. Okay, half acceleration. The body was thrown upwards, whereas the acceleration due to gravity is pulling the body downwards. So projection of the body and the acceleration due to gravity both are acting in the opposite direction. So in this case, A must be taken as minus G into certain time it takes to reach the ground, so T square. So plus X minus X gets vanished, hence we have minus H is equals to UT minus half GT square. Multiplying throughout with minus, you have minus into minus will become plus H equals to minus into UT will become minus UT, minus and minus will become half plus half GT square. So whenever a body is projected from the top of a tower, then the height of the tower is given as H is equals to minus UT plus half GT square. Okay, so the displacement of the body is transformed as H is equals to minus UT plus half GT square. So based on this concept, let us try to solve few numericals, children. Okay, so here we go with worksheet number 8, question number 1. A parachutist drops freely from an aeroplane. So there is a person, so parachute is, you know, parachute. Okay, so a person with a parachute is simply falling from the aeroplane for 10 seconds. After falling, how far it was falling, this person parachutist, he falls for 10 seconds, and then the parachute opens up. Then he descends with the net retardation of 12 meters per second. To make you understand in a better way, let us plot a small picture for this. Okay, so an aeroplane was given, children. Okay, so well, from the aeroplane what was given means that a parachutist was falling freely. Parachute drops means falling freely from the aeroplane. So how far was he falling? For 10 seconds. He was freely falling for 10 seconds. And then the parachute opens up. What happens then? The parachute opens. So until now the parachute was not open. Now here when the parachute gets opened, it will take some format like this. Okay, this person. Okay, so he falls for 10 seconds. This complete distance whatever he was taking from here to here, he took 10 seconds up. Then he descends. Once the parachute gets opened, he falls with some other, not with acceleration due to gravity, some other acceleration or some other retardation he was falling. So then he descends slowly with net retardation of 12 meters per second square. So from here to here, again he falls from what he said was from here to here. Okay, and what was it? 12 meters per second square. If he strikes the ground with a velocity, as he reaches the ground, the velocity he attained is 20 meters per second. Then the height at which he gets out of the plane is. So what he was asked us to find out is the height at which he gets out of the plane. So from here to here, there must be some length. Okay, you're asked to find this total height, children. So very clear that from here to here, he behaves as if a freely falling body. For a freely falling body, the distance is given by S is equals to 0, ut plus half gt square. Freely falling, initial velocity is 0, so S equals to half gt square. So this length is nothing but extends as a half gt square. This height, yes, or H1, I consider the formula would be half gt square because it is an example of a freely falling body. But here, from here to here, he falls with retardation. That means this height is taken as some velocity he has to attain here. Okay, that velocity, some u1 I consider, ut freely falling means half gt square, not gt square, because it is accelerating, that is at square. Okay, children, from here to here, freely falling means formula half gt square. From here to here, he was falling with certain retardation. Okay, so general formula is he attains some velocity over here. If I name it as some u1, that is u1t plus half at square. So you're asked to find out the total height. Total height is nothing but h1 plus h2 you're asked to find out. Okay, so first of all, let us try to find out h1, children. To find the value of h1, what formula are we using? Half gt square, because freely falling. The value of g, we can consider nothing was given, so the value of g is generally taken as 9.8 into, how far was he traveling from here to here? 10 seconds. So 10 into 10. This 2 goes for 4.9 times, isn't it? Hence, the formula answer would be 4.9 into 10 is 49. 49 into 10 is 490 meters. So, this length or this height was found to be 490 meters. Now, you need to find out the value of h2. In order to find the value of h2, what formula are we using? Ut plus half at square. But do you know the velocity over here? No. So, first of all, find the velocity here. Then, the time is also not given. Okay, maybe this formula does not work out. Okay, let us see with another formula. Half acceleration was given, time is not given. So, as the time is not given, you have to go with another formula. Let us discuss it later. Okay. So, first case, first of all, let us try to find out either this formula or another formula, v square minus u square equals to 2as. Final velocity was given. This velocity you need to find out, say u1 and 2as. S is nothing but height. So, this formula will not work. So, have to depend on this formula. So, for this, first of all, let us try to find this velocity. In order to find this velocity, children, you have two options. One is v square minus u square equals to 2as. You can write down, or else v is equals to u plus 80. I'll go with the second equation, that is v equals to u plus 80. V equals to u plus 80 formula. So, v instead of v, what is there, children? Between these two, initial velocity freely falling 0, this is u1. So, u1 is equals to 0 plus, it is a freely falling, acceleration is taken as g and the time was given as 10 seconds. Hence, the value of u1 is found as 9.8 into 10, g is 9.8 into 10, it's nothing but 98 meter per second. Okay, so what velocity was he attained here? This velocity was found to be 98 meter per second. So, you know the velocity, final velocity, initial velocity and acceleration is also known. So, by using the formula v square minus u square equals to 2as. What formula, children? V square minus u square equals to 2as. Substituting, what is the value of v? 20. 20 square minus u square means the velocity attained here, that is u1. How much we have just calculated, that is 98 whole square equals to 2 into. So, this person is traveling with retardation of 12 meter per second. So, retardation means acceleration a is 12 meter per second. Retardation means minus a is given as 12 meter. So, a is minus 12 meter per second. Retardation minus into this unknown height h2 you need to find out. So, after simplification, how much you are getting, children? 20 square is 400 minus 98 square, how much it would be, children? 9604, I think. Okay, 98 square. Yes, it's 9604. 9604 equals to, this is minus 24 h2. So, if you subtract 400 with from 9604, how much you are getting? This is 4, this is 0, 6 minus 4 is 2, 9204 upon minus 9204 upon minus 24 is the value of h2. So, solve this, children. So, how much you may get it? h2 is equals to 9204 upon 24. Okay. So, solving this, I'll go with 4. 4 means 6 4s 24 and here 4 2s 8, 4 3s 12, 0, 1. Clear? So 2301 upon 6 will, how much you'll be getting? 6 3 is 18, 50, 50 means 8 6 ja 48, 20, 21, 6 3 is again 18, 6 3 is 18, again 30, 31, 6 5s are 30. So H2 was found to be 383.5 meters. This height I found to be 383.5 meters, and this height was found as what was H1 we found? 490 meters. Therefore, to find the total height, so H total height is nothing but H1 plus H2 equals to, how much was that? 490 meters plus 383.5, and it was found to be 873.5 meters, children. So from what height was he falling out from the aeroplane? So this is the question. The height at which he gets out of the aeroplane. The total height was found to be 873.5 meters. Here goes your answer. 873.5 meters. Okay, children. So initial height was half gt square. To find out this height, I tried substituting, find the value of u1 from the formula v square minus u square equals to, v equals to u plus 8. I got u1. Substituting in v square minus u square equals to 2as, I got the value of h2. So as h1 was already calculated and h2 was calculated here, the total height was found to be 873.5 meters. Hence third option. Okay. So moving to the next question. So next question. A stone is dropped from the top of a tall tower, and after 1 second another stone is dropped from the balcony 20 meters below the top of a tower. Okay. So let us try to understand the same. So first of all, let us consider a tower, okay, of unknown height. So, and from this, from the top of a tower, what was given is a stone was dropped, freely falling. It is an example of a freely falling. After 1 second, another stone is dropped from a balcony of 20 meters below the top of the tower. So this is the top of a tower. Below the top of a tower means 20 meters from here to here. Again, this balcony is, if the height of the tower is taken as h, this balcony height is taken as 20 meters below the top means h minus 20. This height is taken as h minus 20. The total height of the tower was taken as h. Only from the balcony that height was taken as h minus 20. This is the given condition, children. Okay. If both stones reach the ground at the same time, so both stones reaching the ground at the same time, the height of the tower is. So let us see. So first case, if you substitute, it was dropped from a height h, and this is simply dropped means it is an example of a freely falling body. For a freely falling body, formula is initial velocity is 0, so formula will become half gt square. Let this be equation 1. And what was given is, after 1 second another stone is dropped. So if the first stone travels for t seconds, the second one was thrown 1 second later. That means it travels for 1 second lesser when compared to the first stone. So the second stone is falling from here, this position, isn't it? So this stone travels only this distance. That distance is taken as h minus 20 equals to half g. It travels, it was thrown 1 second later. 1 second later means if that was t means this will be t minus 1 second. That's it. Okay. So you have two equations. Just simplify and solve. Children, substituting the first equation in second equation. So h value whatever is there, just replace it in second equation. So substituting the equation 1 in equation 2. So what, instead of h, what I can replace? Half gt square, okay, minus 20 equals to half g This is of the form t minus 1 whole square, a minus b whole square, a square minus 2ab plus b square. So t minus 1 whole square can be written as t square minus 2ab minus 2t plus 1. That's it. Or half gt square minus 20 equals to, take this half g inside, half gt square minus half into 2 is 1. So minus gt plus half g. That's it, children. So LHS, and this is hard HS, half gt square is common. So now simplifying, how much you are getting, children? Minus 20 equals to minus gt plus half g. But here the value of g was asked to take as 10. Hence we have minus 20 equals to minus 10 instead of g 10 plus g is 10 upon 2, that is 5. Okay, bring this minus 20 the other side, this will become, and minus 10t to the other side. Minus 10t, if you bring it to the left side, it will become plus 10t equals to minus 20 to the other side will become plus 20. This is plus 10t and this is plus 20, and already left is 5. So we have 10t is equals to 25, or t was found to be 2.5 seconds. So children, they meet after a time. At what time? So they travel for, the first stone would have traveled for 2.5 seconds, whereas the second stone would have traveled only for 1.5 seconds. But they neither asked you to find the time taken for the first stone or the second stone. They are asking you to find the height of a tower. But to find the height of the tower, what formula do we use, children? H is equals to half gt square. So from the formula we have h equals to half gt square. H is equals to half. G is replaced with 10. T square is replaced with 2.5 square. That is 2.5 into 2.5. Okay. So this is nothing but 2 goes upon 5 times. So h is equals to 5 into 2.5 whole square is 6.25. Hence the height was calculated as 5 5s 25, 5 2s 10, 11, 12, 30, 31. 31.25 meters was the height of the given tower. So option number 4. Is that okay, children? What was the height? 31.25 meters. So moving ahead with the next question. A stone thrown vertically up with an initial velocity u from the top of a tower reaches the ground with a velocity 3u. Simple. The height of the tower you are asked to find out. There was a tower that was given. A stone what was given? Vertically up. One stone was thrown vertically up with an initial velocity u from the top of a tower reaches the ground. This stone after throwing reaches the ground with what velocity, children? 3u. Here it was u and here it was 3u. I told you while upward motion u means at the same height, downward motion also u. But direction of projection upward, this is the direction of projection downwards. Only makes the difference is direction. So if the velocity, magnitude of velocity u here also it will be u only. But this is in upward direction, that would be in downward direction. Okay. You are asked to find the height of the tower. This must be the height of the tower. Yes or no? If this happens to be the height of the tower, here also h. Here the velocity was found. So the initial velocity is known, final velocity is known, height was also known. So substituting our formula, v square minus u square equals to 2as. V square minus u square equals to 2as. Final velocity how much? 3u whole square minus the projection velocity in the downward direction is minus u or u whole square. Actually, it should be taken as minus u because upward if it is taken plus u means downward it should taken as minus u. Anyhow, minus u whole square is nothing but u square itself 2 into. So it is falling downwards with an acceleration because of the acceleration due to gravity. That A is taken as G. In the downward direction, it is taken as plus G. Because this U is in downward direction. Downward direction is taken as plus G. If you would have considered this U, it is in upward direction. So just 2G into, what is the distance traveled? H. So 9U square minus U square equals to 2GH. 9U square minus U square is 8U square is equals to 2GH, or 2 goes 4 times, hence the value of H is found to be 4U square by G. Value of H is found to be 4U square by G. Children, to avoid confusion, take minus here and keep the square the other up here in the powers. Okay, so minus U whole square is nothing but U square. That I wrote directly. So the height of the tower was found to be how much? 4U square by G. Option number 2. Okay, yes. Next question, a body is thrown vertically up with a velocity of 100 meter per second and another one is thrown 4 seconds after the first one. So that means what is the time gap? 4 seconds time gap. Okay, if travels for first one travels for t seconds, this may travel for t minus 4 seconds. How long after the first one is thrown will they meet? You are asked to find out the time of meet. That's it, children. So for this, what we consider is, first of all, consider the first body. First body means thrown vertically up with a velocity 100 meters. Okay, both are thrown up only. Both are thrown up only. So the only formula we will be using is S is equals to UT minus half GT square. So first equation, condition number 1, height H1 is equals to UT, general formula I'll write, S is equals to UT minus half GT square is your generalized formula. Because the body is thrown upwards, acceleration is taken as minus G. That's it. So case 1, if you consider H1 is equals to UT, U is 100, no height was given, 100 into time is t minus half G, let me take it as 10 t square. That's it. After further simplification, you get H1 as 100t minus 5t square. Equation number 1. Over. So moving to the equation number 2. So for equation number 2, this is the first case and now second case. Some other height. Okay, first body travels for t seconds. The second body would have only traveled for 4 seconds lesser than the first. So H2 must be equals to same velocity. Okay. Another one is thrown, not given, but you consider if nothing is given with same velocity. 100 into what time? 4 seconds lesser than the first one, that is t minus 4. Okay, be clear. 4 seconds lesser than the first one. Again, upward motion, half G is 10. Here also t minus 4 whole square. That's it. Instead of t, I replaced every place with t minus 4. That's it, children. So H2 is equals to 100 into t minus 4 plus 2 goes 5 times, sorry, this is 2 goes 5 times 5 into t minus 4 whole square. Is that okay, children? Well, okay, based on that, let us try to equate, because what was given is how long after. So you're asked to find the time the first one is thrown, will they meet? Only time they are meeting. Meeting means they must travel the same height, same distance. Suppose one ball is falling down, the other ball is traveling upward, means the height remains same. That means distance traveled by the first body must be equals to distance traveled by the second body. That means H1 must be equals to H2 because they are meeting at the same height. So according to the given condition, we have since H1 is equals to H2, let us substitute. H1 means 100t minus 5t square equals to H2 means 100 into t minus 4 is equals to, minus 5 into t minus 4 whole square. So if you solve this equation, you may get the value of t. So let us try solving this. 100t minus 5t square equals to 100t minus 400 minus 5 into t square minus 8t, a minus b whole square, a square minus 2ab plus b square, that is 16. Okay children, so this 100t gets cancelled. Minus 5t square equals to minus 400, this gets inside, minus 5t square plus 40t, minus and plus is minus, 5 into 6 is 6 5 is 30, 80, that's it. Okay children, so let us try solving this. Again this my 5t square and 5t square has gone. What you are left with? 40t, this is 40t, 4 minus 400 minus 80 will be minus 480 equals to 0, or 40t is equals to 480. 0 0 gets cancelled, t is equals to 1 and 4, 14 seconds. Sorry, 4 2 is 8. 12 seconds. So the both stones meet after 12 seconds. So here goes your answer. The both stones meet with after 12 seconds. Is that okay children? So this travels for t seconds, the other travels with t minus 4 seconds. Just equate the two heights because their meeting position is at the same height. If you equate the two heights, you get the value of time as t is equals to 12 seconds. That's it children.